Alright, hello again. This is Jeff Scott, and I've been coming at you with the PowerPoint presentations for the 152-143 Beginning Java Programming class for the Spring 2016 semester at Blackhawk Technical College. I've done the first two chapters, Chapter 1, which was kind of an overview of programming, and Chapter 2, which was kind of an overview of JavaScript. Now I'm going to go into Chapter 3, which talks about the decision structures of JavaScript. Next we'll go into Chapter 4, and Chapter 4 is on the different looping constructs, so you know where we are and where we're going. So in this chapter we'll discuss the if statement, the if-else statement, how to nest if statements inside of one another, the if-else-if statement, logical operators, and finally how to compare string objects, because you can't use a regular type of if statement when you're working with strings, and you'll see that in just a minute. We'll also talk about variable declaration and scope, the conditional operator, the switch statement, and finally displaying formatted output using System.out.printf, which basically Java ripped off from the C programming language, and String.format. Alright? So, the if statement, as it says, decides whether a section of code executes or not. It uses a Boolean condition. So if the Boolean condition is true, it executes it, otherwise it skips it. Let's take a look at just an unbelievably simple example. Alright, let's go back to our program that we've been working with in here. I'm just going to remove some of this extra stuff that I put in that I really don't need, or at least try to remove it. This machine has been locking up all day for whatever reason. Tell you what, I'm going to try to get out of it and get back into it again. Sometimes that clears it up at least a little bit. And alright, I'm going to have to remove some of this stuff that's in here, so I want to get rid of that and that. There we go. Alright, so go back again, sorry about this, and try to start up the virtual desktop once again. Alright, and I'm going to remove all the extraneous stuff that I put in here previously that I no longer need. Alright, so I'm going to make an unbelievably simple program. I'm going to say int number equals 27. Alright, then I'm going to say if number modulo 2 equal 0, System.out.println the number is an even number. Else the number is an odd number. Now let's think about this before we run it and do anything else. What this is saying is grab your number, which is 27, divide it by 2, and see if there's no remainder. Well, you know that anytime you take an odd number and you divide it by 2, there's a remainder of 1. So, since this is false, this should be skipped, and it should just do this. Alright, so it should come out and say the number 27 is an odd number, if I wrote it correctly, which I think I did. save. And the number 27 is an odd number. Well, that's good. What if I didn't want to do anything? All right, so in other words, okay, it's an odd number, I don't care. So if I leave the else out, what should print here is absolutely nothing. All right, because the number is not even and there's no else on here. All right. Well, what if we came in here and we said, if the number equals 0, all right, then we'd say the number 0 is not even or odd. Else, if number modulo 2 equals 0, then we say the number is an even number. Else, we'll say the number is an odd number. All right, and we should get the same result when we run this. It should say the number 27 is an even number. Oops, sorry. If the number modulo, if 27 modulo, oh, that should have said odd, I'm sorry. Odd. All right, so let's try it one more time. Number 27 is an odd number. Good. Well, let's try it, and let's put 36 in here, which we know is an even number. All right, so we'll put in 36, and we'll run it. The number 36 is an even number. All right, then let's try it and put 0 in there. And it says the number 0 is not even or odd. So it looks as though everything that we have in here works. All right, there's a lot of different ways we could write this. You know, probably the number is probably not going to be 0 most of the time. So I'm just going to remove this for now. Okay, and I'm going to say, I'm going to make this an if, and I'm going to make this an else if, and I'm going to come down here and I'm going to paste this in at the bottom. Now this will work, but I'm not going to get the answers that I expect. Because it's going to take 0 and it's going to divide it by 2 and there won't be a remainder. So it's going to say the number 0 is an even number, even though it's technically not. And it's because of the order in which I put this stuff. So the number 0 is an even number. So if I want to make sure I check for 0, even though it probably won't happen very often, I have to put that check first. So I have to check if number is equal to 0 first. All right, so now when we run it, whoops, I gotta save. Now it says the number 0 is not even or odd, which is what we'd want. Now, I took a little detour right there because I just wanted to show you some working examples of this. So, as mentioned right here on the slide, the if statement decides whether a section of code executes or not. It uses what's called a Boolean condition. So it's something, whatever's inside of the parentheses, and the parentheses are mandatory with an if. And if you use an else if, one or more else ifs, it's also mandatory. And this has got to be something that resigns itself to being true or false. If it's true, you do this. If it's false, you skip it. All right, so notice what they have here. If cold outside, wear a coat. So if it's not cold outside, you're not going to do anything in this case. All right. So if cold outside, if you want to do a bunch of stuff, wear a coat, wear a hat, wear gloves. So the curly braces there are mandatory. I always use curly braces, even if there's only one line like we had here. I still would have surrounded this with curly braces. But the author is saying that it's not mandatory that you do that. All right. Most of the time, as mentioned here, when you use Boolean expressions, you use them along with what are called the relational operators. Greater than, less than, greater than or equal to, less than or equal to, and not equal to. And in particular, please look at the last two examples. If you're checking for equality, you need a double equal sign. A single equal sign will not give you the right answer. And when you are looking for inequality, it's an exclamation point followed by an equal sign. Sometimes that's read bat 0, bang 0, ball bat 0, or different things. But the point is, in some programming languages, if you want to check for an inequality, all right, for something that's not equal, so in some programming languages you say like if x not equal to 3. That does not work in Java. Not in Java. In Java you have to say if x not equal to 3. Okay in Java. And it's not equal, not minus, not equal. There you go. So these are your 6 relational operators. Okay? Here are some examples, but I just went over one, which I think hopefully it makes sense. More examples. All right. As it says, even if a statement spans more than one line, technically it's still one statement, so you could take something like this and write it like this, but you very rarely, if ever, see it written that way. It's just too hard to read like that. And you very rarely will see it without the curlies. Typically the curlies will be put in there also. So they give you some rules of thumb here. It says the conditionally executed statement should be on the line after the if. It should be indented. It doesn't have to have a curly, though it still is highly recommended that you do put one in there. If curly braces are used, the if statement is ended with a closing curly. Okay? Now, if you put in something like this and you don't put in the curly, that means if expression is true, you will do statement 1. But if it's not true, you won't do statement 1. But regardless, since this stuff is not in curly braces underneath the if expression, you will always do statement 2 and statement 3, regardless of whether or not expression is true or false. So you'd want to put that inside of parentheses. All right. Oftentimes when you work with this stuff, when you work with Boolean variables, as it says, sometimes that's used to monitor the condition of something that's in a program. All right? And when you're working with Boolean variables, sometimes you call those variables flags. So as it says, when a condition is true, you might set a flag to true. And then you can check the flag. Now, what the heck does that mean? That means this. All right, again, we'll just look at a quote, regular example, unquote, with all the stuff that we've been doing here. So let's say we came in here and we have another variable underneath this that says Boolean. All right, we'll call it married, and we'll set it equal to true. All right, so what the author is saying is when you're checking this, if I want to check if married is equal to true, I can either say this, if married equal true, all right, or I can say this, if married. So in other words, this is a shortcut for this. All right, for this. In just the same way, I can also come in here and do this. I can say if married equal false, and a shortcut for that would be if not married. All right, so you start to see how you can use some of this stuff. All right. Okay, if you go and you decide that you want to compare characters, single characters, as it says, characters can be tested using the relational operators. Characters are ordinal, so there is some order to them in the Unicode character set. All right. So in this case, A is less than Z, so it would print out A is less than Z. Okay. All right. So we looked at the if, and I've already shown you both an if, but what if, I also showed you the else when we first did this. We said, again, if the number was evenly divisible by 2, we printed it was even, else we printed it was odd. So you've already seen that. If you've got an if that appears inside of another if, it's called a nested if. Now, they give an example, and I'll go through it when we go over the actual stuff that's in the book, but let's suppose we've got a situation like this. All right? So, let's suppose, all right, let's just say Jeff is going to throw a party. All right? To get into the party, you must be an IT student. Also, you must be greater than or equal to 18. All right, so both of those are true. So I could write that as this. I could say if, let's just say, let's say we create a Boolean flag. So we'll come in here after we do this. So those are some comments, but we'll say Boolean, and we'll call it IT student, okay? And we'll set it equal to true. And we'll say int age, and we'll set that equal to 30. All right, I'm just making these values up. All right, so we can say in here if IT student, now if I want to, remember I can say equal true. I can say that, or I can just say if IT student, which is the same thing, and age greater than or equal to 18. I can write it like that. In fact, I'd probably write it like this. I like to put each of my things that I'm checking in their own set of parentheses. All right? And in this case, both would be true. So, in other words, I could come in here and I could do, if I wanted to, I could type in a System.out.printf. You can attend the party. All right, why? Because both of the conditions are true. Else, I'm going to print out you cannot attend the party. All right. So, in this case, for the else to be true, let's say the person was only 10 years old. So they are an IT student, but they're not greater than or equal to 18. So they cannot attend the party. Well, another way that I could write this if I wanted to, all right, there's nothing wrong with the way it's currently written. Nothing. But I could also write it like this. I could say if IT student, all right, then inside of there I could put in another if that said if age greater than or equal to 18. Then I could come in here and write you can attend the party. All right? Otherwise, regardless, they can't attend. So I could say just leave it like that. And I could come out here and write another else here if I wanted to. And say you cannot attend the party. But I'd also need another else down at the very bottom here, which again would say you cannot attend the party. So it would say the same thing. Okay? So why am I showing you all this? Well, I'm showing you that anytime you have a complex condition like this is an and, two ampersands. So if both of these are true, we do this. If either one or both are false, we do this. But here, we do this. Only if this is true do we check this. So anytime you've got a complex condition with an and like this, you can rewrite it as a series of nested ifs. Do you want to? Much of the time, it's a matter of what's easier for the programmer to look at and understand. All right? So here's a nested if. Is it cold outside? If it is, then you ask if it's snowing. All right? So it's an if within an if. And there you see it. As it says, curly brace use is not required if there's only one statement, but it does make more sense to do it, and proper indentation makes things easier. The program works no better because this stuff lines up. You could have taken everything and had it all line up right here. That would have been a poor way of coding it, but you could have done it that way. When the compiler actually goes through and begins to prepare your code to be compiled and set into bytecode, one of the first things it does, it doesn't need any white space, so it gets rid of all the white space in your program anyway. So you put that there not for the system, but you put it for you and for your own edification, so it's easier for you to look at something and figure out what's what. All right, I showed you an if-else if already too. There's a good example. And in fact, I'm going to write this one. I like this example that much. So I'm going to go over here where we've got this. Okay? And I'm just going to set up a grade here. So I'm going to say int grade equals, and we're going to do some jacking around with this, but at first we'll set it equal to 100. All right? I'm going to get rid of all this code that we put in here previously. Okay? And I'm going to put in this. If grade greater than or equal to 90, and I don't know how I got that black space in there, but I did. So if it's greater than or equal to 90, System.out.println, you got an A. All right. Else, if it's greater than or equal to 80, well, not 90, 80, you got a B. Else, if it's greater than or equal to 70, you got a C. Else, if it's greater than or equal to 60, you got a D. And just an else on the end. Else, you got an F. All right? So think about it, play computer, and think about this right now as far as what the grade is the person would get. We have currently come in here and set grade equal to 100. Is 100 greater than or equal to 90? Yes, it is. So it should print out you got an A if we did this correctly. So I'm going to save it and run it. And it says, whoops, it says, come on, you got an A. Let's change it from 100 to 90. Well, 90 is greater than or equal to 100, so it should print out in here, you got an A, which you still did. But as soon as you move down to an 89, now it should say you got a B, and it does. And when I go down to 79, it should say you got a C. Oops. And when you go down to 69, it should say you got a D. And when you go down to 59, it should say you got an F. So you can see all of that worked. But sometimes this is confusing to people because you're like, wait a minute. 59. Let's go back to what we had when we started. 100. All right. Well, 100 is greater than or equal to 90, but it's also greater than or equal to 80 and 70 and 60, etc. But with the way an if works, as soon as it finds a condition that's true, like this one, it does it, and it skips everything else till the end of the if. This is all one collective statement. So with the 89 that we put in there, it was not greater than or equal to 90, but it was greater than or equal to 80, so it does this one. All right? And that's the way you find a lot of code written, is like that. So I've already shown you the and. All right? There's also an or, and there's also a unary. So let's take a quick look at those. Well, I showed you this example before, where I said, if you're an IT student and your gauge is great. If I change it from and to or, what does that mean? That means that anybody who's an IT student or anyone who's greater than or equal to 18 can attend the party. So if you get down to here, all right, you're not an IT student and you're less than 18. Because if either one of those conditions are true, the whole thing is true. So with an and, everything has to be true. With an or, only one of the conditions must be true. And also, Java does what's called short-circuiting. So since this is an or, it comes through here and it says, are you an IT student? Notice it is. So it doesn't even make this check because since it's an or, it only needs one thing to be true. So it never has to make the second check. If this was false, and this was an and also short circuits. So it says, is that true? No. So there's no sense in checking the second one. It never does it. That's called short circuiting, and that's done for you automatically. The last one, so if I come through here and I say Boolean married, and I say equal false. All right, then someplace in here if I say if, in fact, let's not do that. Let's just say, so if I want to say if married, you already know that's a shortcut for if married equal true. All right. But what if I wanted to do something just for single people? Then I could say if not married. Okay? And that would only then check for people where married is equal to false, as it is right here. So remember, that is again a shortcut, for if married equal false. All right? Again, the idea is I'm going through a bunch of examples in here. I'm going to go over some examples when I go through the actual book, and we'll go over some examples in the classroom as well. Well, that wasn't too good. I think it was on about, I don't know where it was, 26 maybe? All right. So there's and, there's or, and there's not. There's the truth table for an and. So unless both of them are true, that's the only way the condition is true. Otherwise, it's false. With an or, unless both of them are false, the whole thing will be true. And not inverts. So if it was true, it becomes false. If it was false, it becomes true. I just mentioned the short circuiting to you. All right. When you have a complex condition, you do nots. Anytime you have a not, you do that, and then you do ands, and then you do ors. That's the order of precedence in these. So if you've got a very complex condition, if not x and y greater than 6 and etc., you do all the nots first, all the exclamation points, then the ands, which are your double ampersand, then your ors, because that's going from the most restrictive to the least restrictive. So with the operators we've looked at thus far, this is their order of precedence. This is also shown in your book. All right. When you compare two string objects, and I want to show you this, it's not exactly shown, I'm not going to exactly show it the way it does in the book, but I'll just show it to you this way. What is going on with this? Control key is stuck. All right, so if I say string name1 equals Bob, string name2 equals Bob. This might surprise you. If I say if name1 equals name2, so you probably think, well, that's Bob and Bob. That's going to be true. That's actually is false. Because when you use a double equal sign with strings, what that says is, do these two things point to the same area in memory? Not do they hold the same value, do they point to the same place in memory? So when I do this, somewhere out in memory, and I'm just going to make this up, maybe at memory location 1000, it puts Bob in there. All right, the zeros and ones that would be equal to Bob. And then maybe this one, it goes to memory location 2345. So what it's doing is it checks and it sees, do these both point to? So it says, well, this one points to 1000 and this one points to 2345, so they're not equal. If I want to check to see if name1 and name2 actually hold the same value, I have to say if name1 dot equals name2. So I have to write it like that. That actually is true. So that's how you check string inequality. All right, you use the dot equals. And when you're working on this, maybe you don't care about the case. So notice there's an equal ignore case that you can use. All right, as well. All right, we've talked about scope already, and we mentioned that if you define a variable inside of main or inside of another, whether it be main or whether it be another method, that it's known by default only within that method, so it's local to that method. All right, that's what they're talking about here. All right, let's look at the conditional operator, which is also called the question mark colon operator. And I'm going to show you a little, it's not a trick, but just to show you it. Boy, oh boy. So if I come through here and I do this, I'm going to say int num1 equals 27. Int num2 equals 36. And then I'm going to say int max, and I'm not going to give it a value. All right, now I'm going to say if num1 greater than or equal to num2, so if that's the case, max equals num1. Else, max equals num2. And that's totally fine. It's syntactically correct. Everything that's in there is fine. There is absolutely no problem. It's fine to run it like that. But if I want to write it and use the question mark colon, which provides a way of writing it with a little less code, I can say this: max equals num1 greater than or equal to num2 question mark num1 colon num2. So I'm replacing all of this code right here that you see in blue with this code in one line. And how does that work? Well, it says do my if statement. All right, it doesn't have the word if in it, but it says do my if statement. If the if is true, like we have here, take num1 and assign it to max. If it's false, take num2 and assign it to max. So either one of these, either this or this, they both work and they both do the same thing. So which one should you use? The one that makes the most sense to you. If this question mark, so this says do a Boolean condition. If it's true, do this. If it's false, do this. But if that's harder for you to understand, then don't use it right now. It's not a problem. So there's the syntax, and again, this is also shown in the book. All right, there's also a switch statement in Java, very similar to the switch statement, basically the same as the one that's in JavaScript. All right, so you use a switch, and you use a bunch of cases. So let's see if they have one in here. They don't have one listed in here, so let's create our own. All right, so let's assume, and what I'm about to show you, I'm making this up. All right, again, what I'm showing you right now, I'm making this up. So I'm going to write a little code again. We know nothing's working here. There we go. All right, so I'm going to say this. Int student1 equals 1. You'll understand why in just a second. All right, so I'm going to do a switch. We won't call it student1. We're going to call it grade. Grade equal 1. Okay? And then we're going to do a switch on grade. And I'm going to say here, case 1 System.out.println you're a freshman. Break. All right. Now I'm going to cheat a little bit here. Case 2, you're a sophomore. I think that's how you spell it. I could be wrong. I don't really care. Case 3, you're a junior. Case 4, you're a senior. And so that's 1, 2, 3, and 4. This will write the word default. All right. So your grade is unknown. So play computer again here. This is like writing an if statement. This is like saying if grade equal 1, System.out.println you're a freshman. Else if grade equal 2, System.out.println you're a sophomore. Else if grade equal 3, System.out.println you're a junior. Else, if grade equal 4, System.out.println you're a senior. Else, System.out.println your grade is unknown. So it's another way of writing an if statement. You need these breaks, because if I left out the break, let's just, for now, if I left out every break, the only one that's not mandatory is the one after default, because it's at the end anyway. But if I left it and wrote it like this, even though the grade's 1, break says get the heck out of the statement. So it would write you're a freshman, you're a sophomore, you're a junior, you're a senior, your grade is unknown. It would write all of them, which wouldn't be what you'd want virtually 100% of the time. All right. System.out.printf allows you to do a little bit of formatting when you're performing console output. All right. So let's look at some examples. All right, System.out.printf hello world. That doesn't show much. All right, but let's look at a real world example, something you might actually use. So if I came through here and I wrote something like this, double hours equal 40.0, double rate equals 25. I can say 0.0, I don't have to, but I'll just double gross equals hours times rate. All right, and if I do a System.out.print line right now, the way we have been doing it, and I say your gross pay is gross, all right, it's going to actually print out your gross pay is 1,000.0. It's not smart enough to put this to 2 decimal places, so it'll print it out like that. So if I do want it to print out with that, I can put out as they show here. I can say, instead of saying this System.out.print line, I can say System.out.printf, and the F here means formatted, and I can say your gross pay is, now I say %F, I'm sorry, %.2F gross. Now what that's going to print out here is your gross pay is, and now it will have 1,000.00. Why? Because this says it's going to be a floating point, even though it's a double. You don't use a D there, you use an F, whether it's floating point or a double or a float. This says 2 decimal places. So if you want to add some formatting, this is one way of doing it. Not the only way, but it is a way of doing it. All right. Again, format specifier, etc. All right. So notice here they just put %F, and it typically goes to 6 decimal places then. Well, you wouldn't want that. That's pretty ugly. So if you change it to .2F, it'll go back to 874.12. There you go. Also, when you come in here, notice what they've done is they put a comma in. Before, this is fairly new to Java, so it says %.2F. All right. So if we go back to our example and we put the comma in after the % sign in the example I gave you. All right. So let's put a third one in here. Now what that's going to print out is your gross pay is 1,000.00. So it's doing even more formatting. All right. So that comma is what magically made that happen right there. All right. You can also do things where you specify a field width. So notice you're saying that it's 6. So in other words, since it's a number, it right justifies it. So it puts space, 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 9 to hold up 6 spaces. All right. You also have this example where it says 6.2, which means that there should be 6. It should be 6 wide, and 2 of them should be decimal places. So this should print here 9 and there's only 2 decimal places, so it rounds it to 9.77. So it's space space 9.77 because that's 6 places. There's also a String.format method where it says it works exactly like the System.out.printf method, except it does not display the formatted string on the screen. Instead, it gives you a reference, so it's something that you might want to use at a later time, is what they're saying. so you can hold it into a variable so you can use it later. And that is it. So I'm going to produce this, and when I come back, I'm going to go over the last one I'm going to do today, which is Chapter 4, Loops and Files.